Hey everybody, this is Miss Watson. I hope you guys are all doing well and had a nice, relaxing weekend. We are back at it today with some more practice on Standard 3 quadratics and quadratic applications. Now, the good news is it's a short week. And so I know you're looking forward to it. I can tell you as teachers are looking forward to it. Even though we only have one day off on Friday, you guys will have Thursday and Friday off. All right. So that said, we thought it would be helpful to have another day of practice with applications because this is, you guys are always asking, like, what are we going to use this in real life? Well, here you go. And while you may not think that these applications are completely relevant to you, these are just different examples of where quadratics are used in real life. Okay. So, first, two problems are when you're given a graph. So, similar to the notes from Friday, so we'll do the first one together, and then I want you to answer the second one on. I'm sorry, we'll do the first one together, answer the second one on your own. Then we'll switch to when you're not given a graph. We'll do the first one together, and then ask you to answer the second one on your own through Edpuzzle. Okay, so here we go. Softball team is practicing catching fly balls. Coach Miller is tossing the softball into the air with an initial upward velocity of 58 feet per second. The height of the ball, h, in feet after t seconds is given by this function, which I'll highlight right here. H of t is equal to negative 16t squared plus 58t plus 4. And we have a graph here that represents this function. And a couple of the points, key points on the graph are highlighted and given to you. Okay, so first question, how high is the ball when Coach Miller first hits it? So what we want you to do with these problems is relate this back to kind of our math vocabulary. The question is asking how high is the ball when Coach Miller first hits it? Two things that I think of. This is initial height, which some of you guys might also think of as a y-intercept. And we know two things. The y-intercept is where it crosses the y-axis, and it is also when x equals 0. Oops. So if we look on our graph, we look for when x equals 0, where it crosses the y-axis. That's going to be right here. So we know that this is our y-intercept. So what is the height, which is the y value? It's 4 feet. And so that is our answer. Next question says, what is the maximum height the ball reaches in the air? Okay, so again, you're looking for keywords here. Anytime you see maximum or minimum, you should be thinking of the vertex. Okay, and if it's asking for height, then you're solving for h, or the y value. Okay, so we want the y value of the vertex. So if we look at our graph, vertex is going to be the highest point. So this is our vertex and that point right here. And this is our y value, so that's the height. So the height here will be 56.563 feet. So how high does the ball go? 56.563 feet. Part C, when is the ball at its highest point? So when is time, and highest point again is part of the vertex. So this time it's going to be the x value of the vertex. So look back, we already highlighted the vertex. This is our x value, so this is their time. So the answer here is 1.813 seconds. Next, it says how high is the ball after 3 seconds? So again, what are you solving for? You are solving for height after 3 seconds or at 3 seconds. So when t equals 3. So what you want to do here is, because it doesn't show exactly on the graph, right? We can't tell exactly what it's at 3 seconds. You want to take 3 and plug that in for time. So it would look like this. H of 3, so evaluate the h function when t is 3, is equal to negative 16, 3 squared, plus 58 times 3 plus 4. Plug that right into your calculator, guys, and make sure you're following order of operations. Okay, so I plug it in, I put negative 16 times 3 caret 2 plus 58 times 3 plus 4, and I get 34. So how high is the ball after 3 seconds? 34 feet. And finally, what does the point on the graph 3.693 comma 0 mean? So on the graph, that's this point right here. So kind of two ways to think about this. So this is time, this is height. So you could answer it like this. At 3.693 seconds, the height is 0 feet. Another way you might be thinking about it, kind of a little going further, what does that really mean? The ball hits the ground at 3.693 seconds. I'll put or, right? Because if the height of the ball is 0, that means that it's hitting the ground, right? So whenever we talk about, or whatever, in case they're on top of a building, but in this case, for all we know, they're on the ground. So if the height is 0, that means it's back on the ground. Okay, I'm going to go ahead and pause the video here so you can do the next questions on your own. All right, this time we are given a graph. It looks like somebody's shooting some shots in basketball. So it says Thomas is practicing his shots after missing all his shots in his games last night. The height of the ball, h in feet after t seconds, is given by the function h of t is equal to negative 16 t squared plus 24t plus 7. And we have our graph. Okay, so you might want to approach it like this. Some of you guys may approach it this way and just say, what are my key points based on the graph? This 0, 7 looks important. That would be my y-intercept. And this up here, that's going to be my vertex. So those are the points that I'm going to use in this question, okay? So how high is the ball when Thomas releases into the air? Again, this is your y-intercept. And in this case, it is 7 feet. What is the maximum height the ball reaches? So this is your vertex. And specifically, the height, which is the y value, so I'll put vertex y value, which is 16. And that's what we highlighted in the blue. Part C, when is the ball at its highest point? So when, this is the vertex, but now we want the time, so we want the x value. So you got to be really careful. Is it asking for the y value of the vertex, or is it asking for the x value? Okay, the x value of the vertex is 0.75, so 0.75 seconds. And how high is the ball after 1 second? Well, 1 second is somewhere right around here, right? But we don't know exactly what that is based on the graph, so we need to plug that in. So we're going to do h of 1. That means plug in 1 for t, right? Or evaluate the function when t equals 1. So this is t equals 1. So we're going to h of 1 is equal to negative 16, 1 squared, plus 24 times 1, plus 7. And again, plug that right into your calculator. I'll read it to you how I plug it into mine. I do negative 16 times parentheses 1 squared, or 1 caret 2, plus 24 times 1 plus 7. Then I get 15. So how high is the ball after 1 second? 15 feet. And make sure that makes sense in the context of the problem, right? That 1 second is after the vertex, or after its maximum height. Well, the maximum height we found in part B was 16 feet, so it makes sense that the ball was starting to come down now. So it makes sense that it would be about 15 feet. And finally, what does the point 0.14 comma 10 represent in the context of this problem? So that is this point right there, which I kind of made too dark, but kind of like we did in the previous problem, right? This is time, this is height. So we can say at 0.14 seconds, the ball is at 10 feet. Okay, let's move on. Now, what happens if you're not given the graph, but you are given the equation? Okay, so you can't just look off the graph. You're going to have to do a couple calculations on your own here. So first up, we have Connor, who can be mischievous, was standing on his uncle's rooftop deck and catapulted a water balloon into the air at an initial velocity of 88 feet per second. The height of the water balloon, f of x, in feet after x seconds is given by this function. Okay, so no graph this time, all right? So it says how high off the ground was the water balloon when it was catapulted? So how high off the ground? This is asking us for a y-intercept, which if you don't remember, you can just, this is the c value in standard form. This is also when x equals 0. Okay, so some of you guys right away might know it's 77 because that's the value of c because this is in standard form. But if you're not sure, you can always plug it in like so. So f of 0, so when x equals 0, equals negative 16, 0 squared, plus 88 times 0 plus 77. And everything is going to cancel out in the first two terms, so you get 77. So your answer here is 77 feet. Part B, when did the water balloon reach its maximum height? So when means we're solving for x, which is time. And again, anytime you see maximum height, you should be thinking vertex. Okay, so the x value of the vertex. So recall, x value of the vertex is opposite of b over 2a. So if you need to up here, you can put this, like to write it either above or right underneath it. This is ax squared plus bx plus c. So in this case, b is 88, so opposite of b, so negative 88, divided by 2 times a, so 2 times negative 16. And you get negative 88 divided by negative 32. And as a decimal, you get 2.75 seconds. So when did the water balloon reach its maximum height? At 2.75 seconds. Now, how high did the water balloon go? So now this time, how high? This is solve for y, which is height. Okay, how high did it go? Its maximum height. So this is going to be the y value of the vertex. So take the 2.75 that we found in the previous problem, plug it back in to the original function. So at 2.75 seconds, what is the height? And again, plug this right into your calculator. So negative 16 times 2.75 to the power, or caret 2, plus 88 times 2.75 plus 77, and I get 198. So how high? 198 feet. So it went pretty high. Okay, last question for this one. How high was the water balloon at 5 seconds? Again, what are you solving for? How high? So this is solve for y, which again is our height, at 5 seconds. So when x equals 5. So f of 5, that means you plug in 5 for x, negative 16, 5 squared, plus 88 times 5, plus 77. Plug it in the calculator, negative 16 times parentheses 5 caret 2, plus 88 times 5, plus 77, and you get 117. Okay. I'm going to pause the video so you can go ahead and try the last problem. Make sure to continue the video after you answer the questions so you can see if you got your answers correct. Okay, so Oliver got a model rocket kit for his birthday and wanted to try it out. He launched it from the roof of a building. Its flight path is modeled by this function, where f of x is the height of the rocket in feet above the ground, and x is the time after the launch in seconds. Pretty similar, okay? We're looking at time and height together, okay? So first question, how high off the ground was the rocket when it was launched? This is asking for the y-intercept, which again is when x equals 0. So I'll go ahead and just plug in 0 for x. Now some of you guys might be thinking, do I have to do that because I know it's a c value? And the answer is no, you don't have to do that. Give me 1 second. I think I lost the video. Okay. No, you don't have to do that. So if you already know that the y-intercept is when x equals 0, then you know it's going to be 32, but this shows the work. So my answer is 32 feet. Okay, part B, how long did it take the rocket to reach its maximum height? How long? So this is solve for x because x is time when it reaches its maximum height, which is the vertex. So vertex is opposite of b over 2a. So opposite of b would be negative 98 over 2 times negative 16. Work that out. You get negative 98 over negative 32, which is 3.0625. So how long did it take? 3.0625 seconds. How high did the rocket go? Okay. So how high? So now we are solving for y because that's our height. Okay, and this is how high, so this would be the maximum. So now this is the y value of the vertex. So plug in the previous answer, 3.0625, into our function. So this is again, sorry, let me rewrite that. Y value of vertex. So plug in 3.0625 in for x. So you're noticing there's a lot of calculator work on these problems. So you want to make sure that if you have a calculator other than your phone, please do use that. It's going to be most helpful for you in this class and going forward in math. If you don't, you always have the option of your phone, but I would suggest maybe using Desmos because Desmos works really great as well and is a great tool to use. And I get 182.063. Okay, and I would probably round that, but it doesn't specifically say it, so I'll leave it as is, 182.063 feet. Typically, we might ask you to round that to the nearest whole number, in which case we would say 182 or 181. Okay. All right, and then last question, how high was the rocket at 5 seconds? And so again, how high? So solving again for y, which is height, but this time it's when x equals 5. Okay, so f of 5 is equal to negative 16, 5 squared, plus 98 times 5 plus 32. And we get, I think I typed it wrong. I actually dropped that negative. Make sure you don't drop that negative at the beginning. We had 122. So at 5 seconds, it was 122 feet. And that tells us a pretty good story, right? So it tells us where it started, it tells us where it reached its maximum height, and then one other point on the graph. And there we go. that's it for today. Hopefully, another day of applications give you a little more practice and understanding of how we can apply quadratics to real life. Thanks so much, guys. Take care.